Can we really change the future of energy? Absolutely yes. But honestly, not at the flip of a switch. Of course, change has to start now. And waiting for a perfect solution is wasting time we don't have. So if we can move faster towards net zero by using existing gas technologies combined with renewables, we'll do it. The transformation of energy is a big task, and honestly, we can't do it alone. So we're putting our energy into collaborating with those who share the same vision. Reliable, affordable, and sustainable energy for all. Honestly, when we all work together, global challenges can become global opportunities.
And good morning, good afternoon, everyone. Welcome back. My name is Mingza. She's my co-host, Olga. Welcome back to our Singapore studio. Today is the second day of our Asia Pacific Energy Week. We hope you had a great time yesterday and you are prepared now with a cup of coffee for our second days of discussion. And we had a great turnout yesterday where around thousands of you tuned in from online. They participate in all this discussion we have with regards to the decarbonization topic.
Thank you for introducing me and very warm welcome from my end as well. Good morning, Asia Pacific. We had a wonderful engagement yesterday, and thanks to all of you for contributing and for sharing your comments and asking many questions. We count on you to continue this today as well. As you know, we had a little exercise yesterday asking you what you think how much CO2 we have been reducing since 2005. So in order to get you energized this morning, we would like to continue this and ask you today what your expectation is to reduce CO2 until 2030 compared to 2005. You will see this question popping up on your screen, and while we are waiting on the results, Mingzia, how was yesterday?
Sure, I'll do a really quick summary of yesterday. But before that, for those who have missed yesterday's event, the recordings are available online. So please feel free to go online to have a look at all this really good discussion that we had yesterday. Yesterday, our theme was mainly revolving around accelerating the energy transition here in Asia Pacific. We touched upon climate change. We talked about the fall of coal and rise in renewables. And we also discussed a very important topic of geopolitics of energy. And lastly, the hydrocarbon industry in a decarbonized world. And all this are setting us up for today's discussion, which is regarding designing our future for a sustainable future. So I would like to take this time to also thank all of our partners that supported us, and today will not be possible without them. They are all shown in the screen behind us. They are the German Chamber of Commerce, Asia Pacific Hydrogen Association, Dornier Group, International Solar Alliance, Indonesian Electrical Society, Roland Berger, Institute Engineers of Indonesia, Siemens Gamesa Renewable Energy, as well as Technology Depository Agency. We look forward to continuing this partnership in the years to come and have this meaningful conversation in the near future.
Wonderful. Let me check if we have the results ready. Yes, there we go. So yesterday, maybe you recall, we had about 20%, which was the major responses, how much CO2 we have reduced until today compared to 2005. Surprisingly, you can see a very similar answer for today, the expectation on what we should reduce until 2030. However, a very strong second component is at 40%.
It is.
Which shows our audience is expecting more. They want us to be more green, to decarbonize the future. But how can we achieve it?
Well, it is evident from yesterday's discussion that we must act now and we must act fast. And with that, there has to be collaboration between different parties in the world, and mainly these are businesses and also the government. The government has to set the right policy to drive decarbonization, where private companies have to invest in the right technology, to invest in the right fund in order to bring this forward. So I'm pretty sure that there are many interesting projects that are coming out to drive this.
Exactly. We heard about all the collaboration and interdependency that will rise and get very strong in the future. And we heard two very good examples of those kind. Cindy from Keppel Infrastructure was mentioning a cross-border power trade project, which brings energy from Laos all over Thailand and Malaysia to Singapore. And also Fraser from Sun Cable mentioned yesterday a project that is bringing energy from Australia over Bali to Singapore.
Wow.
Wow, huge projects, I have to say, which also brings us very nicely to our first opening panel of today, the future grid. And how can we connect it all? And of course, while connecting it, we have to ensure that this is also stable and secure for all of us. We have a fantastic mix of panelists for you today, upcoming to answer all your questions. So keep it up and be engaged. Amir from Head of Grid Connection APAC of Siemens Gamesa Renewable Energy. Han-Tek Fong, VP Grid Digitalization Corporate Support of SP Power Grid. And Assistant Director General Strategy of International Solar Alliance, Jagjeet Sareen. And Volker Hild, Grid Stabilization of Siemens Energy. Our moderator for today will be Anchal Mittal, Director of Global Transmission Report. How wonderful to connect this region as she is based in India. And now from Singapore, from us to India, Anchal, I see you're up and ready. The floor is yours.
Thank you so much, Olga and Ming, for a power-up intro. Good morning, ladies and gentlemen, and good afternoon to all of you who are joining us from Asia Pacific. I'm delighted to be hosting this session, which is on electric grids of the future, connecting it all. Thank you to our audience for your interest and participation, and to our panelists. It is a very big honor to have you all of us today to have you all with us today. Ladies and gentlemen, grid operators are facing new challenges as more countries embrace renewable energy to honor their climate change commitments. Increased demand together with decentralized generation adds to this grid complexity. This session explores how intelligent interconnected grids can transport energy across countries, improving access, increasing grid stability, enhancing grid resilience, and augmenting regional energy security. To kick off this session, let me introduce our esteemed panelists. We have Volker Hild, Vice President, Grid Stabilization, Siemens Energy. We have Mr. Han-Tek Fong, General Manager, Grid Digitalization and Corporate Support, SP Power Grid, and Mr. Amir, Head of Grid Connections, APAC, Siemens Gamesa Renewable Energy. Welcome to all the panelists. I'd like to briefly introduce some panel to our audience. Mr. Han-Tek Fong is an energy industry veteran with more than 30 years of extensive experience in electricity transmission and distribution business, including gas operations. Currently, he oversees the development and maintenance of the distribution network management system for the remote monitoring and control of Singapore's electricity distribution network. Welcome, Mr. Han. Mr. Amir is a principal key expert in Siemens Gamesa with 15 years of experience in power system design and analysis. He is currently based in Melbourne and is the head of Siemens Gamesa Renewable Energy's grid connection engineering in APAC. Amir has been heavily involved in grid connection and technical support for numerous power plants, including solar, wind, gas in the Australian electricity network. Mr. Volker Hild holds a joint master's degree in electrical engineering and business administration, majoring in high voltage technology and energy systems. Over the years, Volker has held different positions both in Germany and overseas in project management, strategy, and sales. Prior to this role, Volker was responsible for Siemens transmission solution business in APAC, based out of Delhi, India. Welcome to all of you. Before we dive into a panel discussion and engage ourselves into the grid that we want to create for the future, I invite Volker to set the context for this discussion. So Volker, here's my question to you. Siemens Energy claims to be a partner and driver of energy transition worldwide. What is the role of the grid in energy transition? And in your opinion, is this role underestimated?
Thanks, Anchal, for the introduction, and welcome also from my side. When we talk about energy transition, what does it actually mean? Well, as per the IEA energy outlook, it is expected that by 2030, actually about 58% of the installed generation capacity globally will come from renewable energy. And the majority of this renewable energy coming from intermittent, highly volatile solar and wind power. So it becomes already clear that the ways that the transmission grids are currently being operated and designed will be changing dramatically. And we can see quite a lot of that already in different places, actually globally. A lot of more than 120 gigawatts of interconnector capacity is planned in Europe between 2020 and 2040. We see also that large countries like China are actually saying that they want to increase their grid, the high voltage transmission capability by almost double. And we are not even talking about the aging infrastructure, meaning those assets which are nearing their end of lifetime and need to be replaced over the next 1 or 2 decades. So all in all, energy transition in terms of the transmission, that means we see the electricity demand further increasing and probably growing much more than we currently can actually plan with regards to building it up. And number two, all this needs to be installed and needs to be incorporated in the grid. So what is now the role of the transmission grid in the energy transition? From my point of view, it is clearly an enabler. It doesn't work without the electricity transmission grid to safely execute and move forward an energy transition. And not only an enabler, actually, it's from my point of view, an absolute key. And is the role underestimated? Well, I would say it probably has been in the past. And it is now moving and progressing a little more. I would say there's more interest, more sensitivity being brought to the topic. And I think the panel today is also a good indicator for that fact, that we have a couple of enthusiasts and grid specialists talking about that matter today. So I would say we are moving in the right direction, and let's put more emphasis on that topic, because transmission is definitely future of energy transition.
Thank you so much, Volker, for highlighting the importance of the role of the electricity grid in energy transition and setting the context for the discussion that is soon going to be followed. Before I proceed with the panel, it is time to engage the audience with a poll question. This should be coming up on your screen shortly. So here's the question. What is your progress in implementation of a digitized energy grid? And you have the options. You can please choose the ones that is right for you. The options are not started, planning phase, pilot phase, implementation, or maybe if this is not applicable, then you can select that. As the audience takes its time to respond to this, let us now dive into our panel discussion. I would like to begin the first round of questions for this panel with Mr. Han. Mr. Han, my question to you. Singapore future focus is on climate change and the transition to new energy sources. What is SP Power's what is SP Power doing to maintain reliability while also catering to the evolving energy needs of the future?
Thanks, John. Yes, a very interesting question. And I would like to start with the national objective first, as in that if you looked at climate change, the national objective is to halve the carbon emissions by 2050, and to also reach the net zero emissions as soon as viable by the middle of the century. So what we are doing about this is that we are trying to reduce the reliance on carbon And there are four energy switches that the country is looking at. First is the continual reliance on natural gas. Most of our power generation is coming from natural gas, about 95% of it. And this will continue for a while, but we are also looking at how we can make the machines more efficient and then also to improve the overall the carbon emission of our generation plants. Second is about the opportunity to use solar energy. And as you know, although our sun quality is not that good, but still, I think that is the most promising renewable energy source for Singapore. And the country is looking at a target of 2 gigawatt peak by year 2030. And the third switch that we are talking about, and you probably have heard also over the last 6 months about the initiative of the country to have regional power imports from the various neighboring countries. And this will be an opportunity to tap the regional energy at a more cost competitive and also probably at a much lower carbon emission from various sources such as hydro, solar, etc. And the fourth energy switch that the country is looking at is also to look at emerging low carbon alternatives, such as the utilizing carbon capture, etc., and also to utilize storage energy and probably hydrogen as well as a new source of energy. Now, as you also probably read that Singapore's power grid is one of the most reliable, measured by the performance called SIDI. I'm sure many of you know the supply interruption duration index. It was 0.5 minutes for last year, and we will continue to sustain this number by way of looking at systematic regime for maintenance and also timely replacement of aging assets. And more importantly, now with the advance of technology, we are looking at more remote sensing and digital technologies that we can employ on our assets, so that the health of the assets is quickly established, and then we can have programs to actually look at how we can further improve the performance of the assets. So digitalization for the future is one of the most important point that we are looking at in order to go in tandem with this energy transition that's happening across the world. Yeah. Thank you, Anna. Good job.
Thank you so much, Mr. Hunt, for taking us through some of your very ambitious climate change targets and the actions that are taking place. Also highlighting some of the initiatives in the grid that you're taking place. You mentioned grid digitalization. That's something that we'd like to discuss in the next round, and we'll hold on to the conversations relating to that right now. And I'd like to move on to Amir with my next question. Amir, as a renewable energy solution provider, you have been involved in execution of numerous renewable energy projects in the region. And the recent years are now witnessing APAC countries announce very ambitious renewable energy targets. And these new capacities need to be connected to the grid. So in your opinion, what are some of the challenges do you foresee for the grid planner as they aim to connect this large-scale renewable energy onto their grids?
Okay, then, thanks very much, and good morning and good evening, everyone. As I guess Volker rightly said in the beginning, I guess the transmission networks are the biggest bottleneck maybe at the moment. As I mean, traditionally they have been built around the fossil fuels and the nuclear plants, which were, I mean, normally located nearby load centers. But however, when we talk about massive solar and wind plants, we talk about square kilometers of land, and they are normally, I mean, outside the load centers, and where there is no transmission network, or even if there is one, there is radial long transmission network not suitable for these sorts of projects. So I guess that is the biggest challenge that there is, and there is a big question of what is the price for system security, because the financial viability of these investments are always a big discussion point. You don't, I guess the discussion is you don't want to gold plate a network, but then you have the question of what should be the system security that you expect from these. And like we are living in an environment that the technology is evolving extremely quickly. I mean, the storage technologies are, I mean, they are growing and rapidly in a rapid pace, and the prices are also coming down as we move forward. So there are big questions to ask. I guess the time is really limited, as everyone, I guess everyone in this call is also adamant that everyone is really pushing the targets, trying to bring them forward as much as possible. So I guess that is one of their biggest challenge, and the other one is probably load forecasting. I mean, we know there is going to be a massive growth in, the load, but not clearly known. And it is very country specific as well. In Australia, for example, we have a lot of rooftop PVs in houses which are really volatile. You don't know what they are doing. They could be, coming on and off. We have states that are running purely on renewables and mainly on rooftop solar. And then, of course, there is this emerging electrical vehicles that I guess there is no doubt this is the future of transportation, most probably, and the amount of demand that it is going to cause is also going to be considerable, which again put a big question mark in terms of system security. So I guess these are the biggest challenges. I mean, there are many challenges technically as well, but I guess an answer to these questions are really needed quickly. But yeah, tough task to do though. Not an easy one.
Thank you so much. Thank you so much, Amir, for that very honest and reply and highlighting some of the grid challenges that you foresee for the grid planner. And I believe most of the challenges that you have mentioned are being faced by majority of the countries in the APAC region. And thank you for highlighting those for us.
That's fair.
Moving on, I'd like to bring in Volker to the discussion. And Volker, as as an energy technology company, how do you see the developments in APAC's transmission market taking place, and how do you, how are you looking to convert these challenges into opportunity for Siemens Energy?
Right. Asia Pacific is one of the most fastest growing regions, and the electricity demand will grow to more than 22 terawatt hours by 2040, which is nearly double, so more than 80% actually of the current demand. So when we talk about opportunities, it's huge. And opportunity is one thing, and at the same time we have to deal with all this demand, and we have to deal with all these requests, and I think this is Amir used the word bottleneck, and this actually I think is really a bottleneck here, where OEMs and all the players in the market have to very closely work together to ensure that all the demand is being served properly and in due time. When I look specifically at the Asia Pacific region, I guess it is quite clear that in many places in Asia Pacific, that let's say that if I look at Asia Pacific as a whole, we see different stages in which the individual transmission networks and energy infrastructure is actually in. We see a couple of places where a lot of basic development still has to be done, where a lot of general, I would say, grid development has to be taken on, while maybe in other places we can already go beyond and talk more about also ensuring a much higher degree of reliability and a higher degree of stability in the network with all the new energy mix coming in. And if I look at all that, grid development, the normal expansions and extensions, the grid access topic that Amir was talking about, you mentioned in the previously that also larger interconnectors are being built, especially because, as Amir rightfully said, it is no longer that the power plant is right next to the load center. We now have distributed and much larger distances to cover, at least in the larger countries, not necessarily maybe in Singapore, Mr. Han, but definitely in all across Asia. So I think there's a lot of potential. Let's not forget about the fact that renewable energy means also a lot of contribution, not only from a generation point of view, but also from taking care that renewable energy is not only renewable in terms of source, but that we're also sustainably handling it. And if I look at our what we call blue portfolio, where we are operating switchgear without any fluorous gas. These are contributions also for a safe and I would say sustainable and clean handling of such energy supplies. And ultimately, I think it is also we have to look beyond just utilities and energy providers, but also to the industrial domain, where it is essential that also a lot of change in the industries and in the industrial processes has to take place, so that that a more sustainable householding of energy consumption is taking place. My company has partnerships already with larger companies, including like BASF, for example, to tackle these challenges. So I think grid development, interconnectors, renewable energy, and industrial growth load, these are the three big topics. And operationally, a couple of things have already been shared, and I'm sure during the course of this panel we will touch about digitalization and those things a little more also.
Thank you, Volker, for sharing with the audience how Siemens Energy is looking at these challenges as opportunities, and some of the work that you are looking at to help countries achieve their energy transition goals. Thank you for highlighting that with us. Before we move on, I believe we have the poll results for our first question. Can we have the results on the screen, please? We have the, great, we can see them. So the question was, what is your progress in the implementation of a digitized energy grid? And we can see that 33%, around 34% of the panel, the audience thinks that they are in the planning phase. Then we have another 20% which say that they are currently in the pilot phase. And then we have another, I believe, 15% that are yet to start. And I'd like to start with SP Power, Mr. Han, the grid operator. Are these results different from what you visualized? Mr. Han, I think you're in mute. If you could unmute yourself.
Yes. I think yeah, quite. I would respect the results that's coming from the audience, and they are all sort of from a global audience all over the world. So the development of the geopolitics and the development of the grid and infrastructure itself in all different countries have got their own pace. And based on their economic development as well, they will have their own pace. So it all depends on how they have grown accustomed to the growth of the energy transition, and also how they can adopt technologies in order to build up the grid. So yeah, it's to each his own in a way, and it is a reflection of the reality from the marketplace, if you like. Thank you.
Thank you. Volker, I'd like to take your thoughts on this result. Do you see another opportunity emerging for Siemens here? What are your thoughts?
Definitely. I realize majority said it is in planning stage, and I guess that probably holds true in any case, because as a grid operator, as utility, you're constantly in planning stage for future scenarios, and to ensure that latest developments are currently incorporated, and that load forecasts and such things are being considered. To answer your question much more straight, I would say, look, supporting our customers in the planning stage is something which is part anyway of our, I would say, service and our attitude, because ultimately no organization can handle such huge changes in completely on their own. It is about the close collaboration between the subject matter experts with all the domain knowledge, with the respective knowledge in the countries, with the experts on assets, on technologies, on on also having the experience from other places in the world. And I think this is something where especially Siemens Energy is happy to contribute, simply because we see different development stages and progress in energy transition throughout the world. And I guess Asia Pacific will definitely be a region which can benefit from the experience that my organization, as well as many other organizations, have already gone through, for example, in Europe, where energy transition has started already a couple of years back, and where we're probably a little more advanced. And probably that will help Asia Pacific not to undergo the same learning curve, but can benefit right away from the lessons that we took out of it.
Thank you so much. I'd like to thank the audience for bringing this required twist to the story and helping us steer the discussions in the right direction. Before we move on, I would like to remind our audience to keep sharing their questions for our panelists. You can also name the panelists to whom we need to address the question to. Thank you. We'll now move on to the next round of questions with our panelists. So far, we've heard and discussed the challenges that are currently being faced by grid operators, planners in either integrating renewable energy, ensuring electricity supply, meeting the evolving demand of the consumers. I'd like to now focus our attention to the possible solutions on how we can address these challenges. I'd like to begin with Mr. Han. Mr. Han, Singapore is one of the early adopters of the intelligent and digital grid technologies. How have these technologies helped SP Power in operating and maintaining the grid? And which next technology solutions SP Power is currently exploring or working on?
Thanks, Anchal. Yeah. Yes, it's a very good question in terms of the development of the grid and also how we should be adopting technologies as we move along. So Singapore is indeed an early adopter of such intelligent and digital grid technologies. If you recall, maybe I would share a story. We started off with distribution automation way back in the 80s. And we actually used a Siemen spectrum SCADA system. So for those from Siemen who probably know that we are early adopter, and maybe one of the first few in the Asia Pacific region to have SCADA system or their distribution network. So we had some developments in the early days to develop to cover all our distribution stations in Singapore with the SCADA, the SCADA monitoring of our network, of the 22 kV network, or rather the distribution network in general. And with this, in fact, if you look at the performance of the network, if you look at SAIDI actually comprises of two components: the number of incidents that causing an outage, and also the duration of the incident itself. So if you can prevent that incident happening or reduce the outage time, then your SAIDI will be good. So sometimes in terms of failures, it's very difficult to prevent failures, but we can minimize the number of failures. When it comes to sort of shortening the interruption, the way to do it is by remote switching. And this SCADA system that we have adopted for the distribution network actually helps a lot in system recovery of our outage. Yeah. So then going forward, I think this is always work in progress. Mr. Volker has mentioned about things that are always work in progress, and we are thinking of things that is always ever changing. There's no destination for such digitalization or infrastructure development. We are always on the move. So going forward, I think over the years, we have introduced quite a lot of digital technologies, such as condition monitoring and also power quality management systems that we have embarked on our assets and our network. And going forward, I think we have also last year in the conference in Singapore, the Singapore Energy Week last October, we have started our first prototype of a digital twin for our network. What this digital twin is all about is about creating a replica of the actual assets and the network. And this representation of the network will give us an insight to the asset health and also the impact of the asset failure if something happens. So there's a lot of prediction, a lot of analysis based on having to create the replica of the assets so that when this is fully developed, then you enable Singapore Power to better plan and operate and maintain the national grid through modeling, simulation, etc. So this is one of the things that we're looking forward to in order to enable the grid to be more intelligent and to be better able to prevent failures and also to make sure that we are able to restore supplies, restore failures as quickly as possible. So these are the few initiatives that we have put in place. Yeah, thank you, Ajahn.
Thank you. Thank you, Mr. Han, for sharing some of the recent technological solutions that have been adopted and are also being explored. We also wait eagerly to see how these solutions help the in-grid management and the benefits SP Group experiences by deploying them. Before we move on to our other panelists, let me also turn to the audience for our next poll question. This should now be coming up on your screen. The question is, what is most needed for the future development of a digitized energy grid? And some of the options that you can choose from is funding the most critical factor, know-how, technology, policy, or supply chain? Do key in your answers for this poll result, and we'll discuss this in a couple of, we'll take the opinion of a panelist on this poll result in a couple of minutes. Coming back to our panel, I'd like to ask Amir my next question. What new and emerging technologies are going to play a key role in keeping a secure energy grid that can deal with the serious reduction and eventually elimination of fossil fuel or nuclear power plants?
Okay, thanks very much. I believe energy storage are going to play a key role keeping this renewable a viable option for the future. I mean, just the nature of this renewable plants, whether it is solar, wind, or other forms of energy, they are predictable, but the matter of the fact is they could be hampered by the weather, by the availability of the sun, wind, and so. So the energy storage is going to play a huge role. And with energy storage, other technologies like, technologies like grid forming inverters are going to play a huge role in making sure that the network is secure and it can deal with specific scenarios that are typically handled by the synchronous machines, the likes of black star's capability, being able to hold the frequency, create an island that can work on its own, and maybe push the grid toward the smaller microgrids in certain areas. So I believe these are going to be key. And on top of these, with this AI, artificial intelligence, I firmly believe is going to play a huge role. I mean, in every area, in terms of load forecast, whether it is load forecasting, even protection, dispatch of this generation, it is still new, but it is growing extremely quickly. So I believe it is going to play another key role. The other thing is, I mean, the overall technology, case in point in Australia, I guess the network was surprised and overwhelmed by the amount of interest in putting the renewable plants in. Like unthinkable is happening now in Australia. Now we are running, EMT studies in the whole network, which 5 years ago, computational wise, it was just unthinkable. But it is happening now, and I'm sure there will be a lot of lessons learned for the rest of the world as well, as I believe it is the first country that this is happening. So on the technology side, rapid growth, rapid change, and new technologies emerging every day, which is making it very exciting, certainly for us living in this era. As an engineer myself, very excited to be part of this. I mean, we don't have a mundane day. It's a new thing every day. So, yeah. Yep, thanks very much.
Thank you, Amir, for sharing your perspective. Indeed, some of the solutions you've highlighted, energy storage, new evolving grid technologies, all of these could be a game changer for the grid and can help utilities move towards their energy transition goals. I'd like to move on to Volker. With the offshore wind coming in, microgrids, EVs, hydrogen, they're all coming into play. Power grids are getting more and more complex. How can we manage these complex grids?
Great. I think Mr. Han, Amir already gave good indications in which direction, and Amir is speaking from the bottom of my heart with a lot of his his comments on storage and on stabilization technology, which is anyway my core business, I would say. First and foremost, there's actually a large variety of technologies available already in the market. Everything which has to do with fast reacting voltage control, to provide inertia and short circuit power in absence of larger rotating masses of power plants. And of course, also technologies which enable dynamic load flow management, which altogether make sure that the transmission grid remains stable and resilient. The high fluctuations is actually the problem, not only in general energy production, but also with the ripple effect of having unstable voltages and frequency situations, which are simply not appreciated. For a stable and resilient operation of the network, we need stable voltage, we need stable frequency, to ensure smooth operation, and most importantly, also a stable power supply for all our consumers, whether they are private, domestic, or industrial. And this is something where a large variety of technology is existing. Australia, what Amir said, is a very good example, who started many, many years ago with a lot of reactive power compensation and voltage control already. And now with a huge infeed of renewable energy, with all these solar farms being interconnected and wind farms, we see also these rotating mass of synchronous condensers coming back on, and a quite high demand on that. So I think this is definitely moving forward. We see huge demand in the market, and I can only encourage everyone, as a connection to my earlier reference to my earlier statement, to closely collaborate with the stakeholders and players in the market to ensure that the demand can be served properly. Two more aspects I would like to add here in my answer, because the message came a couple of times already on digitalization, and I appreciate that Mr. Hahn said that he actually has a full digital twin of his network in Singapore. So this is definitely a step beyond. I would say having a network representation and doing the necessary analysis and planning with respective network models is quite highly common, and is something where my organization and many others are contributing to ensure that respective simulations can be performed and see where the exact need is and where instabilities may occur, and what type of technology, be it a small be it just a small reactive power compensation device, or maybe a larger interconnector, would do best and would support best. And digitalization, going beyond just planning and digitally representing the grid, is also for me a matter of data processing. What about as-is data or real-time data from key assets, not only from power plants, but also from key assets, be it interconnector, or even coming down to the individual product. There's enough products available in the market, including from us, which are able to provide the necessary real-time data, which will help also operating and more safely, not only from a maintenance point of view, but also from a load management point of view. I think we are still in the beginning here, in a nascent stage of the potential that can be unleashed by digitalization. And I think ultimately it is also a matter, again, in which development stage a grid is already in. And it probably makes sense to first ensure the basic needs can be met and fulfilled, and then take it step by step.
Thank you, Volker, for your insights. Also, agree with you on the fact that there needs to be a planning. We have to move stage by stage. One has to identify where we are, what technology suits us the best to address the unique demands and challenges of each country. So thank you for sharing your insights on that. We now, I believe, have the results of the poll 2 question, and we asked the audience, what is most needed for the future development of a digitized energy grid? And can we have the results, please? Yes, we have an overwhelming response here on the that technology is what is needed for the future development of a digitized grid, and this is closely also followed by policy. The audience believes that having the right policy in place is also a key enabler for digitalization of the energy grid. I'd like to actually start with Volker here. Your thoughts on this? Did this result meet your expectation?
Actually, it does, and I have to admit that it matches my personal opinion, but I'm actually surprised. I thought that maybe the focal point in Asia Pacific would be a little different, but I do agree that technology and policy are the key drivers. Technology, I think I gave my view already in my previous statement, and especially when it comes to policy, I can only say that is absolutely crucial, and I think Asia Pacific can learn a lot from, for example, Europe in this regards, where we are not lacking good intentions, but lacking a certain speed in not only policy making but also decision making, approval processes, permitting, and all those things. And I think that is something where a lot of need for change is there, and a lot of sensitivity for collaboration, for speeding up processes, and simply to move forward, to decisively move forward, and not kind of plan things till death.
Thank you, Volker. Mr. Han, what about you? Does this go in line with the thinking of SP Group?
Yes, this is surely the key drivers that we are looking at, technology and policies, very in line with the audience here, and it is actually a productivity tool, if you like. As you know, the grid covers quite a big geographical area. I mean, not so big for Singapore, but still you need physical people to attend to certain things that are not available for technology to do. But having developed technologies or capabilities that can use technology instead of a human being to do such work, I think it is really a helpful thing in order to make the grid more resilient for the future. I think this is something very in line with what we are doing for the initiatives for the grid. Thank you.
Thank you. Amir, your quick input on this. Do you think this will further add to the challenges that you'd mentioned already for the grid operators?
Exactly, and I believe, I mean, it is really good to see that the industry is aligned, certainly in APAC, and the ball is rolling. I mean, we touched base on the technology side of things, but policy is equally important, maybe a bit more important, as it is the enabler for the rest of, the technology to follow. I mean, that is what it drives investments to these renewables. I know we all have hard targets to reach, ambitious targets, which are really very good, but policies are the enablers. And the whole thinking should be changed, if you ask me. I mean, we are going to have new emerging markets that probably have never thought of before. I mean, we're going to have special auxiliary, frequency markets probably, which again, they need their own policies. And we're talking about the generation here. The nature of load is also changing a lot. So all of these should be handled by correct policies to make sure that we're always on the right track. Because, yeah, to be sure, I mean, the track is being defined by those policies, and the technology is doing its best to enable those things.
Thank you, Amir, for that. I'd like to thank the audience for your participation. Your contribution has highlighted important insights to our discussion. I would also like to remind our audience to keep sharing their questions, keep posting their questions for our panelists, and please do also name the panelists you'd like the question to be addressed to. Extending our discussion from the poll result, I'd like to just touch upon a bit on the needs for policy and regulatory framework. This was highlighted as one of the biggest factors that could enable digitalization of energy grids. So I'd like to begin with Mr. Han. With the current electricity import concept announced by EMA, and you also mentioned how you're also looking at, creating, preparing for regional power market. Singapore is expected to play a vital role in the regional energy market and also help share clean energy sources. How are you preparing the grid for the future regional power market?
Thanks, Anchal. Yeah. If you look at the literature surrounding all the trials and trials that we're trying to do in Singapore, earlier on, I think there was a mention about having to trial a 100 megawatt import into Singapore via the ASEAN grid from Laos to Thailand to Malaysia and to Singapore. This is a 100 megawatt trial. This was mooted by the energy ministers and it is to really iron out the commercial, legal, and all the frameworks required for energy imports. So that's happening. And then there's also another trial recently announced for 100 megawatts also from Malaysia. And in order to look at the carbon emissions targets that we want to achieve in the next 20, 30 years, very ambitious target of halving the carbon emissions of current number by 2050. Recently, the government has announced about the energy imports from the neighboring countries. And we are looking at a target of about 4 gigawatts by year 2035. So in terms of the proportion of the energy, 4 gigawatts over the denominator of the energy, we're talking about maybe 30 to 40% of energy imports going to come into Singapore. This is probably one of the ways in order for us to abate the carbon emissions by importing green energy from the neighboring countries, mainly from solar or maybe from possibility of hydro energy coming from some of the neighboring countries. So in SP's perspective, if you are looking at importing 30% of the base of energy, it is quite significant here. I'm sure all of you know that any spinning reserve that is less than 10% is you are actually living on a very, very, very borderline case. So now we're talking about 30% of energy import. I think there's something that is huge, and certainly all the way from the value chain, from infrastructure, from control and monitoring, from stabilization, etc. I think this value chain of activity need to happen. The infrastructure, for example, you need to look at the landing points and the intake stations so that you are better able to absorb the huge quantity of energy. That's one. Secondly, is about how control and monitoring systems can provide a way to provide stabilization to the grid. We are talking about renewable energy, maybe a lot from solar. So solar has got a huge reputation of being very intermittent. So really, the monitoring and control system needs to be very, very adept and very, very precise in order to make sure that we don't deviate from the system frequency too much. So this is something that the grid will have to do in order to accommodate the huge amount of energy imports that's coming into the country. Yeah. Thank you.
Thank you. Thank you, Mr. Han, for sharing SP Group's plan and the work being done to prepare the country's future grid for future energy exchanges. Indeed, highlighting again the role of technology, how this could facilitate in a smooth operation and enable energy exchange. I'd like to ask Amir, going back to the we mentioned that policy, it could be a possible, is a challenge for digitalization and for adoption of technology. What do you think needs to be done? What do the countries need to do to fast track renewable energy development in terms of the current regulatory framework?
I guess everyone has to be very open-minded with the technologies, because again, we are all used to a traditional form of technology and how it was run before, and changing that mindset isn't an easy thing. So it certainly needs more dedication and really being, again, the technology is just moving rapidly. So you really need to be up on your toes, monitoring what is happening in the world, in the technology side of things, and also what is going to drive the future in terms of renewable technologies themselves, running the network. And also, I guess one thing that ties this policy to the technology is the grid codes, which again, they have been normally written years ago for the round synchronous machines, which as humans we managed to master them, I'd say. But now we have to master a new type of technology. And that really needs a collaborative work between the OEMs, network operators, I mean, the consultants, the people that really know the network, and all needs to happen with a really open mind. Because again, it is a complete shift. These are things that we are not used to see, we are not used to control this way, but there are solutions. I guess technology has advanced enough that, as Volker rightly said again, we have mainly the technology available. It's just putting all the pieces of puzzle together and making sure that we have policies allowing them to be used.
Thank you, Amir, for your inputs on that question. Thank you so much. I believe we can now move on to our audience. A lot of questions are pouring in for our panelists, and I appreciate we have a very intelligent and smart audience today, and some very interesting questions here. So I'd like to begin with the first one. The question, I'd like to ask Mr. Han's input on this question. Regional connectivity versus domestic distributed generation. What is your opinion?
Anchal, can you miss the first part? What is it all again? Sorry, the question.
So the question is regional interconnectivity versus domestic distributed generation. What is your opinion? Which one do you think works best for maybe Singapore, and what is your opinion on it?
So if I understand your question correctly, you're talking about distributed energy.
Versus regional interconnecting with other countries versus just domestic distributed generation to meet your energy needs and the challenges. So what do you see works well for Singapore maybe?
Yeah, okay, perhaps maybe I will start by saying that space or real estate is actually a premium in Singapore, and it's a very small place. You really understand how big Singapore is. Just 700 square kilometers, so small island. So the land use probably has got better priorities for other use. So in order to realize the energy import and also in terms of cost benefit analysis, it makes sense more to import energy. Generally, I think for renewable energy, where you need huge space of reservoir to collect water, hydro for the matter, or for solar panels, right? For solar panels, typically for 1 megawatt solar plant, you probably need about 1.5 hectare space of land. So you can imagine the geography of Singapore doesn't allow such large-scale solar farm or large-scale hydro or pump storage, if you like, that can be accommodated in Singapore. So the general direction is that still dependency on energy imports, but also to continue to develop on our gas generated energy from our gas turbines to make it more efficient going forward. In other words, to let it work harder for less input that we put in. So generally, I think this is the context of why I think it's more beneficial in terms of cost benefit analysis to have energy import from the region. Thank you.
Thank you. Thank you, Mr. Han. I'd like to ask this question to Amir. Maybe Volker can add to this. Is there a risk of higher curtailment with increasing share of renewable energy, especially in countries like Vietnam, India?
Okay, I can answer it from Australian perspective, and it certainly is. We have regions in Australia now that are, I mean, regularly constrained. And those constraints, again, come from different reasons, mainly system security, voltage transient stability, and the ability of the network basically to transfer that power. Again, the same question that we talked about at the beginning. We have a concentrated area, very ideal for solar and wind, 1,000 megawatt of generation, but the lines are only allowing for a small, maybe 50% of it. So that is mainly one of the reasons of constraint. And of course, the other thing is a control interactions, for example. Again, the way these renewable plants are controlled is totally different to the classical machines that used to be. So again, these are very collaborative and collective work of the whole industry is needed to streamline these controls and make sure that they can operate together. So I would say yes, there is a high chance of curtailment. And of course, I mean, planning, again, this is a big question for the transmission network planners. How much the capacity you plan for? I mean, these can come concurrently at the same time. In a good day, you can have your solar at your peak, your wind at your peak, and I guess some constraint might be expected at the end. So reality sometimes is a bit harsh, but yeah, I would say yes to that question.
Thank you. Thank you for that response. Volker, would you like to add to this?
Yeah, I basically agree with both what Mr. Han and what Amir were saying. Chances are higher, but I say chances are higher, not that it will come that way. And I think it is in everyone's interest and to avoid it by proper planning and by operating the new energy mix and the grid appropriately. And there are a couple of things were already being said. I see a lot of efforts being put into exactly this topic of planning of operations, and that's why I'm not pessimistic at all. I'm rather optimistic that since everyone is aware of the challenges, I think there's a good chance also that it can be properly covered in the planning stage. And ultimately, let's not forget about that. It is really a matter also of tolerance. How much of tolerance in the energy supply am I accepting? And Mr. Han gave his incredibly great performance numbers of the Singapore net already. Anchal, yourself, I have lived in India. We know that a lot of interruptions are there taking place on a daily basis, which no one likes, and the stakeholders are trying to improve it. So I think tolerance level and improvement level is something where there's a lot of play, I would say, and I'm looking optimistic into the future. But yes, in general, chances are definitely higher.
Yep. I have to agree with you, Volker. Maybe I wasn't clear. I mean, as is, if we don't plan well for the future, that's where we're going to expect constraint. And I guess these are all very good indications for further investment and improvement in the transmission networks mainly. So they're good, good indications to start the work.
Thank you. We have come to the close of our session, and I do believe it has been a very engaging and a very insightful session with all of you. And a big thank you to all our panelists. We would all agree some of the key points that we've all I would agree on is that planning is very, very important. One must also look at the technology that suits best. There is a need for a policy to come into play for us to be able to move towards energy transition, create a grid that is intelligent, reliable, use the technology. The technology options are all out there for us, but it is for the planners, for the policymakers to create an environment for the use of these technologies that can help create and move us to energy transition goals and create a very reliable, intelligent grid. So with that, I'd like to again say a big thank you to all our panelists for their insights, contribution, and inputs. I hope this session has been an engaging one, as it has been for me. If you have any further questions, please feel free to reach out to us at Siemens Energy or follow us at our Siemens Energy LinkedIn and Facebook for more post updates. Thank you all once again for your participation and your engagement. See you all at 11:30 a.m. Singapore time for another very interesting panel that is coming up, which is on driving the hydrogen revolution in Asia.